Hello and welcome back to our channel. This is day 9, and as I have promised before, I'm just going to speak about some of the tools that you use in networking environment to troubleshoot the problems and also to check the desired outcome of the commands that you have run before. You want to make sure that everything is as expected. So what we are going to do is we are going to talk about testing connections, and the specific tools that we are going to use is going to be ping, which is going to be one of them. Traceroute is going to be another one. And also we are going to check Wireshark again. That's going to be the tool to make sure that all the packets are sent as expected. So Wireshark, of course, is not a capturing tool. It is a capture tool, but you do not really capture all the packets. You capture just the desired packets, and you can just select them, sort them, and then check some of them to make sure that everything is working normally. So we're going to talk about some of these. The first tool that we are going to talk about is ping. And you can check the slide. I'm just going to read the slide through for you, and then I'm just going to show everything on Wireshark, because when you see that, that's going to be much easier to understand. So ping is an ICMP packet. ICMP is Internet Control Message Protocol. ICMP packets are not IP packets. They have their own protocol number. So when I say ICMP, we have some IP header on top of that, but the actual thing is ICMP is its own protocol. So let's just take a look at an ICMP packet in here. I'm just going to go to the lab. As you can see in this lab, we have 6 routers that are configured. We might have a reachability from the beginning to the end. And let's say that each one of these routers are connected to different parts of the network. So let's say that there is a device on this side of the network on the left, which is eventually connected to router 1. And then it wants to reach to a device which is connected to router 6. Say the device that is connected to router 1 has an IP address of 1111, and the device which is connected to router 6 has an IP address of 6666. So if I just go to router 1, for example, and what I'm going to do is to say ping 6666, and you can see that ping is right here, and you can see that I am typing this in privilege mode, or as we call it, enable mode. In privilege mode, you don't have to add anything in front of the command. All you need to do is just to type the command. And privilege mode, most of the time, is where you just go for verification commands and making sure that everything is working just fine. So if I hit enter, you can see that there are 5 exclamation marks here, which means that I have sent 5 packets, and all of them have been returned successfully. So the replies, as a matter of fact, have returned successfully. This exclamation mark means that everything is working as expected. So I can just see that this is what we have. Now let's say that I'm trying to reach to something that doesn't exist, or I don't have a route to that. When I say I don't have a route, this means that I cannot really reach to that. So let's say that I'm just trying to ping something like 7777 and hit enter. What is going to happen is I'm just going to receive some timeouts. And these timeouts by default are something like 2 seconds in here. 5 packets, and none of them are going to get to the destination because there is no such destination in our network or any other network that we can reach to that. So you can see that it says the success rate is something like 0 of 5, which is going to be 0%. In this case, as a matter of fact, we had 100% success. As we can see, all of them have been sent and received. Now, when you do ping, you're going to receive some extra information, which is very important. So the first thing that you're going to see is the success rate, and this is going to be 100%. It should be, as a matter of fact, 100%. The first time that you're doing this, it might be one less, which means that one of the pings are not going to work. And the reason for that might be the ping, the ARP messages. So we try to ARP the destination if we do not have any information about that. And in that case, if we don't have any information, then what is going to happen is we are going to try to ask the destinations, what is your MAC address? That is going to be an ARP message. Okay, so let's just try to see the packets in action. I'm just going to capture this E00 on R1, or I can do it on R3, it doesn't matter. So I'm just going to say capture E00. The capture window is going to open, and this is Wireshark as map capture, and then this is going to show almost all type of packets that go and come, but I can filter this. So I don't really want to see all these packets in here. What I want to see is just a few of the packets. So those packets are going to be ICMP. So I just type ICMP up there and hit enter. This is going to show me all the ICMP messages that go here. So let's go back to, let me just say, skip this version. Let me just go to R1 and try the ping one more time. So let's say from here, I'm here 6666, and you can see that this is successful, and the captures is here. So if I just go to here, I sent 5 messages, and I am receiving 1, 2, 3, 4, 5, 6, 7, 8, 9, and finally 10 messages, which means that 5 of them are outgoing, 5 of them are incoming. So I'm trying to source the packet from 10131 to destination, which is 6666 in the beginning, and that's an echo message, which is called a ping, and that's a request. As a matter of fact, if I want to see more information about that, I just need to click on here. I can just I can double click on this. This is going to open the window itself, or you can just keep it simple and check everything in the pane down here. So you can see that this is going to be a frame. A frame is a layer 2 piece of data, or let's say data unit, as they call it, DU or PDU, protocol data unit. Then on top of that, we have a MAC header, which is Ethernet header. And this is, you can see that the source for MAC header is this MAC address, and the destination is going to be this MAC address. This means that we know about the destination's MAC address, which of course is going to be the next router's MAC address. Then we have on top of that an IP header, as I told you before. And then on top of all of these, of course, this is going to be an ICMP message. Let's open ICMP message and see what we have inside this. If I open this, it says that this is a type 8, which is echo ping request. The code is 0, and there's a checksum, which means that the packet has been created and sent correctly. There is no disintegrating inside this. And then we have the checksum, which is good, and then some stuff in here. But the most important part is going to be this data information inside that. You can just check the data. What is the data? You can see that this is a random piece of data which is created for us and sent to the destination. So there is no specific thing inside this, but that's a random message. Okay, so we have the ping, and then finally we have the echo reply. So the first one is echo request. The second one is the reply of that. So you can click on that, and again, you can see the ICMP header information inside here. One of the most important parts is going to be this response time, which means that how long did it take for my message to go, and then I get the reply, which is round trip time. Very important piece of information. And if you just come back here, you can see that it says the round trip time, the minimum was 1 millisecond. As a matter of fact, it doesn't really go to this level. You can say this is 1.621 millisecond, which is a little bit more than 1, less than 2. That's the average. This is the exact one actually, because it's here. But what we have here is the minimum is going to be something like 1. The average was 1. As a matter of fact, this is rounded again. And finally, we have the maximum, which is going to be 2 milliseconds. This is a very good round trip time. As a matter of fact, inside my network, that is because every device is very close to other devices. But if you just increase the length, then this is going to increase for you. Not exponentially, just based on the length. That's a direct proportion to the length of the link that we have in here. But again, that's a good as a good amount of average in here. Let's go back to our slides. Okay, so we sent the local message and we check basic connectivity with that. So what happens if I do not really have reachability to the destination? We will receive some messages, as you saw. For example, those dots here means that I have timeout. I have not received any information from the destination. Either the destination doesn't exist, or maybe I don't have information about that. Sometime I receive something like U. U means unreachable. ICMP unreachable. This means that the destination is unreachable due to firewall issues, or an access list, which is stopping the messages from going or coming back. And most of the time, you do not really receive that, because if you have this is going to be kind of a security issue. So we really need to disable this feature to make sure that others are not going to know about us. Okay, let's go for the next one. The next one is speaking about how ping works, which I just showed you. And if I just go to here, there are use cases which are going to be important for us. What are the use cases? So we want to test the connectivity and reachability to the destination. We want to verify the gateway or DNS service availability. Okay, what is DNS service? Okay, let me just show you this in action. So if I go to my topology, where is my topology? Here. And this is, as a matter of fact, my stuff. Let me just close this because I don't really want to have this anymore. Stop and quit without saving. Okay, that's okay. So if I try to reach to something like, ping, let's say, google.com, you can see that it says that unrecognized host or address or protocol not running. This means that I don't have any DNS resolution solution in my network. DNS resolution means that it's going to get the name, it's going to return the IP address, and then that IP address is what you need to get to the destination. In my case, as a matter of fact, as you can see, there is no such thing. So if I want to get to the internet, let me just do something. I'm going to stop this step in this device. Then I'm going to add a network. The network is going to be the management network in here. Management cloud. And cloud is going to be a good icon for this. So I'm just going to click on save. And let me just change this to internet. So I'm just going to say this is internet. So save it. And then I'm just going to add a link from here to the internet. So Ethernet 01 is going to connect to internet. Let's say Ethernet 03. Okay, I'm going to save. And then I'm just going to start the router one more time and configure this Ethernet 02. So this is going to be a way to reach the internet. I have a gateway. The gateway is going to be my service provider's router, which is connected to me. I don't really see that because I don't really care about that. But I know that on the other side there is a gateway. My gateway in this case is going to be 192.168.100. That is my gateway. So everything that I do not have reachability to, I'm just going to send it to gateway. Also, I'm just going to use that DNS services on the internet. So how can I do that? I can just say, okay, this is my name service, and I'm just going to reach to that. So let's just do this. Let's go back to R6. I'm going to hit enter, and R6 is up. Then I'm going to say interface E03 in global configuration, of course. Interface E0/3 that's going to have an IP address of 192.168.100, let's say 254, 255.255.255.0. This is the IP address. I'm just going to say no shots. And then I'm going to try to ping because I am in global configuration. Well, first of all, I need to have a do in front of this. Save the configuration first. I'm going to say do ping 192.168.102, which is my gateway. If I ping it, the gateway is going to show up. Like I said, the first one is dot. This means that the first one, I didn't receive the response in time, and the time is 2 seconds. This means that I was trying to reach the destination. I didn't have the information about that, so I sent an ARP message to that. And that ARP message now responded with this, and then this means that I have information about the destination. The rest of the messages go and come back and okay. So that is what we have in here. What about reaching to the internet? Can I reach to the internet? I need to say that this is my gateway. So for that, I need to add a new command. I'm just going to say IP route. I'm going to say anything that I don't have. 0000, 0000, and then there's going to be 192.168.102. hit enter, and that is here. Now if I say ping like 8888, which is a Google DNS service, then I'm just going to hit enter, and you can see that I have reachability to here. What if I ping a name, google.com? You can see that it says unrecognized host or address. So what I need to do is to first of all say my DNS server is going to be 8888. So I'm just going to say IP DNS server, or IP name server actually. IP name server is going to be 8888. Hit enter. And now I'm just going to try to ping one more time. It says I need to say IP domain lookup. Hit enter. And then try to ping again. This time you can see that I can ping google.com. This means that I have information about this because I have received it from 8888, and then I have received this IP address. It said that to reach to google.com you need to ping this one, and the system of course did it automatically for me, and now I have reachability to the destination. So this means that I have information about how to get towards the destination. So as I told you, now we have this ping tool to check our gateway, which is, like I said, 192.168.102 in my case actually, and also reach to the DNS service, as you can see in here. So ping is going to help us a lot in this case. So let's just continue. We have, like I said, latency and packet loss, and also ping blocks, and you're going to receive something like you, or if that is configured, then ICMP and reachables are not going to be received by you, and then you're going to receive something like dot. Or the next one is traceroute. This means that, and on different platforms, of course, you see different names. For example, on Windows, this is called traceRT, or traceroute, as some people call it. On Linux, it's called traceroute. On Cisco iOS, of course, it's going to be called traceroute. The actual thing that traceroute does is path discovery. This means that I just want to see how I go to destination from this point, and there might be multiple ways to get to there. So traceroute is going to show you how many paths are available towards the destination, and if for each one of them, of course, it's going to show you the probable next hop. Next hop means next rather online from inline from you towards the destination. Let's go to our topology here. So pin tab. What I have here is R1, and I want to reach to R6. And from here you can see that I can go to R3, then to R5, to R6. I can go to R3, then to R4, then to R5, then to R6. I can go to R2, then 4, then 5, then 6. You can see multiple paths are available for me to get to the destination. But am I going to use all of them or not? Let's just try. Okay, so first thing that I'm going to do is trace route from source to destination. So I go to a router 1. I'm going to say trace, and you can see that trace route is like this. Then I'm going to say 6666 and I hit enter. This is going to tell me that the path from the source to destination is this one, 10133, which is router 3. After that, we are going to go to 10355, which is router 5. And after that, this is going to be 10566, which is router 6. So the actual path from the source to destination is going to go from here. I'll just use another color, which is this one, and a little bit thicker. So it goes from here to here, and then to here, and then towards the destination. So I receive this like this. So what is a trace route? Let's just capture again. I'm just going to go capture E00 in here. I want to show you what traceroute is going to look like. So traceroute, if I go back to my slides, is going to be ICMP message again, like what we had on pings, but it could be, of course, UDP probes as well. So let's just check this. So I'm going to say, I'm going to check. Let's just have all of them, doesn't matter. We are going to filter them later. So if I just go back to router 1 and try this trace route again, hit enter. So a bunch of messages are going to appear here. Some of them ICMP, some of them UDP. So let's just check some of them. The first one, which is up here, that's a UDP message. Well, you can see that UDP has an ICMP message attached to that, based on this bracket that you can see in the beginning. So if I check this here, it says that this is an IPv4 header, and on top of that we have this UDP message. So if I open this, it says that the source port is this one, the destination port is this one, and then if I just go down, this is the information of the UDP packet, and then we have the IP header, which has an IP source and IP destination. Okay, great. What about this ICMP message? If I click on that, this is the ICMP header. You can open this and then you can see that the type is not 8, 8 was for ping, the type is 11, which is for ICMP for traceroute. So if I just go down, there are some more information about that. The IP header has a UDP on top of that. You can see that this is ICMP. Then inside that there is another IP packet and the UDP. So this is why these two are linked to each other, because on top of ICMP we have a UDP, or let's say inside the ICMP, as a matter of fact, we have a UDP message. So this goes to the destination and comes back. But this is not just 3 messages. You can see that we just sent one, but we see a lot of information here. So the first one is from router 3, which is adjacent to router 1. The next one has been received from router 5, which is adjacent to router 3. The next one is from router 6, which is adjacent to router 5. So what these messages mean is important to understand. It says that we are trying to send the first message, which is this one, with TTL of 1. So if I just open this IP header, inside here you can see that time to live is 1, which means that after 1 hop this should expire. So R3 receives a message and say, okay, you're trying to reach to 666H, which is very far from me as a matter of fact, but your message has a time to live of 1. So this is going to say, okay, time to live is exceeded. So I have to send you a message back to so that you understand that this is, as a matter of fact, not going to go through. I am the final destination of the packet that you just sent. R1, based on this, could understand that the first hop is 10133. Okay, so it tries the second ping, or let's say second message to 6666, but this time it goes with a TTL of 2. So if I just go for the next one, now if I open here, you can see that this is TTL of 1. Then it goes for the next one, which is, let's see, where was that? And the TTL is going to be here, 10355. Now this time you should see a TTL of as a matter of fact 2. So this is 1 because this has come back to here. Let's see. It seems that we don't have that message in here. But as a matter of fact, the next one is going to have a TTL of 2, which means that I'm sending this message to the destination, which is 6666, and that's going to have a TTL of 2 because I want to see which one is going to be the next one. And the reason for that is this. I send in this to here, and because the TTL is 2, it is going to be sent to 5. 5 is going to say TTL is exceeded, and then it's going to return the message to R3. R3 is going to send it here, and the TTL, of course, is going to show as 1 in this case. But as a matter of fact, what we are trying to do is to send the messages with higher TTLs so that we just go for the next hop, and then the next hop, and then the next hop, and then get to the destination. That is what we have in here. So we are going to send the messages one by one, and then we are going to receive them, and finally we are going to see the destination. And destination, of course, is going to give us information about what we have in here on the path towards the destination. Let's just try to do something else. I want to see if I can get to router 2. So on router 1, if I try to ping 10, 10, 2, 1 2 10 10 10 1 2 2. Head enter. It says that this is not reachable. You can see that. What is the reason? The reason might be misconfiguration of router 2. The reason might be some other problems that we have on router 2. And I need to do this. I need to go to router 2 and say, okay, show IP interface brief, because I'm trying to see if this 10122 exists in here. It says that this is configured on Ethernet 0.1 on router 2, 10.1.2.2. And this is configured correctly on the correct interface, as you can see. What about router 1? I'm just going to check the IP addresses on here. Show IP interface brief. So here it says that 10.1.2.1 has been configured on Ethernet 0.2, which we don't have such interface configured on R1, as you can see. So this is a misconfiguration on router 1. So based on that, I can just go to configuration mode. And I'm going to say default interface E02, default interface E02. Then I'm going to configure interface E01 with an IP address of 10.1.2.1. And the mask is going to be 24-bit. I hit enter, and then I'm just going to save the configuration, and I'm just going to ping 10.1.2.2. The same ping is going to be successful, so we just saw that. And if I try traceroute, of course, this is going to be the first hop available in here. What if I want to ping 10.244? So I can just say ping 10.244, and ping is successful. And if I just say traceroute 10.244, you can see it goes to router 2 and then gets to the destination, which is router 4. There are some other paths, of course, and they can be used, but because this is the best path towards the destination, so you can just select this one in here. So we have this, and then based on TTL, of course, as you saw, this is going to increase, and then it's going to find the next hop towards the destination. So that is how traceroute, of course, works. And the use cases: identify routing paths and network hops, detect where delays occur, of course, because we have some information about the delay as well, right? Then spot unreachable segments or loops, as you saw that. Useful for ISPs and when troubleshooting. And this star means that there is no reply. H means there is no route. Let's just check this. Going back to here, I'm going to go to R6. I'm going to say traceroute google.com. Hit enter. Of course, do traceroute because we are in global configuration mode. And it tries to check to see what google.com's IP address is in the beginning using DNS service, and then we are going to see our gateway, and after that this is the stars that we have in here. Stars means we have no reply. Either the replies are suppressed or the reply doesn't exist. We know that we have reachability to google.com, right? So if I just press Ctrl Shift 6, this is going to stop the traceroute. Then I'm going to say do ping google.com. So I hit enter. I have reachability to that. This means that for security reason, those messages that I was supposed to reach that, I do not really see that. And this means that I have reachability, but I cannot really see what the path is based on security. Some networks do not really want to expose their IP addresses or their designs to us. But this is how we have information about the destination. H means no route. This means that I cannot really reach the destination because I have no information about that. Once again, if I just go back to my network here, if I try to, let's say, go to R1 and say traceroute 7777, hit enter, what I'm going to receive is source because there is no information, or sometimes H because there is no path towards the destination. So I'm just going to disable this. And then we checked everything on Wireshark. We saw CMP messages. There are some other types of messages which we are going to go through in the next videos, as a matter of fact, and we are going to work with them. So we saw the live demos, everything was nice. But there are some troubleshooting tips. The video is already run, so I'm going to just speak about them a little bit fast. The ping successful means that basic connectivity is okay. If ping fails, you need to check the IP as we did. Check the gateways or firewalls. Traceroute shows where connection fails or slows, because we can see the timeouts there, as a matter of fact, in front of the traceroute. Wireshark, of course, reveals packet level behavior as you saw it. And combine these tools for full visibility, and you're going to have a nice troubleshooting set of tools in here. So let's say recap, and then we are almost done with these basic tools. If this video was helpful, please subscribe to our channel. Also, hit the like button and the bell button so that you are going to receive the notification when there is a new video. So hope to see you in the next videos.